What can you tell us about your project without revealing any secrets?
I'll tell you all the secrets. So this is called TurnTouch. It gives you beautiful control. It's a 4-button remote control, and the 4 buttons perform actions like changing the lights, changing the music, controlling all of your hardware, so smart connected devices like Belkin Wemo, Nest, thermostats, smart locks, Philips Hue lights, etc., as well as software, so Mac, music, video, presentations, and then custom apps like an alarm clock, a meditation app, a fitness app, etc. It comes in 3 models. They are mahogany, Hadouk, and rosewood. This is my favorite. And on the back of each remote is mother of pearl inlaid with the logo, the TurnTouch logo. And if you look at the logo, you'll see not only is it T over T for TurnTouch, it's also the electrical engineering symbol for a capacitor. That is no mistake.
How did you come up with the idea for TurnTouch?
That's a good question. Well, it kind of came to me in a flash. I know that I had a few problems that I wanted to solve, and I didn't realize that they were all related to the same answer. So the problems I had were I wanted to be able to watch videos on my Mac, but I also wanted to play pause and change the next, play pause, change the volume. I wanted to change music on my Mac. I wanted to change my lights in my home, and I also wanted just control of things like an alarm clock. I had all these different problems, and I thought, if only I could control all these different devices at once. And I didn't want to have to use my phone because A, my phone was docked, and B, like, you have to, pull out your phone, you have to unlock it, you have to find the app, have the app sync, and then you have to like tap, 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 and then have something happen. So I really just, for like the common repetitive actions that I do constantly, changing volume, playing music, or just like skipping tracks, I wanted something really simple. And then I was driving on the 101 from Mountain View to San Francisco, and in a flash, I just saw in my head a remote control, and I thought, can I do this in 4 buttons? Maybe 5, maybe 6, maybe 3. 4 buttons was perfect, and then I came up with the name, TurnTouch, and all that happened within a span of about 15 minutes. And I remember when I came up with the idea, I realized that I was going to spend the next 3 years of my life working on it. Like, no joke, it is no different. This is exactly what I had in my head 3 years ago. I didn't think it would take 3 years, but I just started screaming because I'm like, this is the idea I've been waiting for. And I knew it was so simple, but it would also prove to be a challenge just in terms of building the hardware, and then of course learning how to build the hardware. I had no idea how to build any of it, but I knew that I wanted a challenge to be able to learn how to build these things.
Tell us about your background. What got you into hardware?
Sure. So in school, I studied art history and computer engineering. So my background was already in how to build hardware, although I had a software focus. So all the hardware that I ended up having to build for my project, I had to learn at the time, so in real time. But I had a history of building small hardware projects just for myself. So the first hardware project I built was a interactive photo frame for my girlfriend. It was for her birthday. And it's a little photo frame that in real time downloads our Facebook, Flickr, and Instagram photos that we take, and it displays them on a little screen. It was hooked up to a Raspberry Pi and had a motion detector, so it only turned on when we walked in front of it. Very simple, just a little bit of software glue to tie those things together. But it was physical. You could touch it, you could see it, and it impressed people. So a little bit of ego combined with a little bit of hardware know-how, and it just kind of picked things up from there, teaching myself laying out circuit boards later on, how to model 3D plastic, and then how to machine wood. So, and I built a few other projects as well, mainly art projects that got a very good, had a very nice energy about them, and people really liked them. And so I kind of fed off that for a while until I finally have my first commercial piece of hardware.
What is the most difficult thing to get your device manufactured?
Well, that's easy. The most difficult thing about getting this thing manufactured is clearly the wood. So both kind of the saving grace and the most difficult thing about this is that it's small. Because it's small, it doesn't take a lot of raw material. So I can source the raw material from the States, send it over here, and we can cut it up and we can get, about a dozen of these per board foot of wood. That's no problem. The problem is when you're machining wood this small on a CNC, there's a tendency for wood to kind of come apart when it's being machined. So the way the grain works in wood is it's a bunch of long grains and they're running like this and they're all parallel to each other. And normally when wood has tension and you're like bending wood like this, it snaps like that. And you've seen it before. It's just, that's how wood looks when it breaks. But when you're machining something like this and you have little tabs on the side, this is such a small piece of wood that really the ratio of the grain, the actual lines of grain, to the surface area is so much smaller than it would be on any other piece that's larger. What ends up happening is the grain doesn't split, it ends up actually just falling apart. And so you have remotes that, as they're being machined, just fall right out of their work holding fixture. So that's clearly the most difficult thing, because as wood is a natural material, every part of the wood plank is different. So you might have knots, or you might have grain that interleaves differently. And so where it might machine well on one plank, it will actually be disastrous on another. And because we're using a vacuum table, it's sucking the wood down. If you have a breach, so you have, a board foot is about yay big, you've got 12 remotes in here. If you're machining one piece of wood and it falls down, or it falls off, or it breaks out somehow, you have a breach in the vacuum, which means the whole thing comes apart, and you've just ruined 12 remotes. And that is by far the biggest pain point we have in manufacturing this thing, at a reasonable price point and in reasonable time. Everything else, if I open this up, there's just plastic inside, there's a PCB inside. Those things are trivial to do. Everyone knows how to do them. PCBA is easy. Injection molding is pretty easy, especially the way I designed this, where everything can be made on a 3-axis mill, as opposed to undercutting on a 5-axis mill. But wood, by far, is one of the most difficult materials you can work with. Thankfully, because it's so difficult, it presents kind of a barrier to entry where most people don't want to touch wood. They want to deal with aluminum or plastic, or even glass and steel or other materials that are much easier to work with. But because I've put in the many hours of effort to getting wood machined at a very nice contour, I have a product that doesn't look like anything else on the market. So it's both a challenge but also an opportunity.
How were your experiences in Asia Innovation Tour? Did you find it what you were looking for?
Well, yeah, so the experience was phenomenal, and I've heard this from a number of other people on the trip. This is one of the best experiences of our lives. We got to spend a week with about 36 other creators, and then again a few dozen more experts and manufacturers and machinists. So people who are dedicated to building things as independently spirited as I am, everyone else is. So you just have this incredible energy about the whole tour, which means you don't sleep for a week, but that's fine because you can sleep, after your product ships. Mm-hmm. So meeting everyone was, we all became very good friends almost immediately. We established instant rapport. So that was definitely one of the biggest positives of the tour. In terms of trying to get what I need, I met so many different OEMs, assemblies, testers and verification services, suppliers and people who can source materials, machinists and factories who can all develop and make different parts of this. So we even met designers who did critique how I built this, how I designed it for manufacturing, and even how marketable it will be in the end. So having the ability to talk to all of these super smart, very experienced people was a phenomenal experience. I would do it again in a heartbeat if I weren't so tired from not sleeping for a week.
So any advice for aspiring hardware creators?
Yeah, I have a bit of advice. So the one piece of advice that I think everyone should follow is essentially don't keep your project a secret whatsoever. tell everybody you can. Every single person you meet, obviously, that is at all related to technology or manufacturing or anything, if they're at all tangentially related to your field, talk about your project. Everyone has a different perspective. You might assume that people only have some naive perspective that they don't know how these products are made. Great. If they have a naive perspective, it means that they come from a fresh outlook. And if they don't know what you're building, you have to explain what you're building. And the process of explaining what you're making over and over and over again helps you hone down your pitch. But the key to doing that is you have to tell everybody. You can't keep anything a secret. No one is going to steal your idea, whether it's a smart idea or a stupid idea. If it's a smart idea, someone else has already built it and has minted a fortune on it, and you're late to the party. If it's a stupid idea like mine, no one even cares, and then it's up to you to prove people wrong in how stupid your idea is. There's no sense in keeping ideas a secret. If you share the ideas, the biggest benefit is that you get to then defend your idea against a litany of smart people who know more than you do about small things, and they'll grill you. The reason that's important is when you do come on this tour and you go to talk to various manufacturers, they will grill you in ways that you haven't been grilled before. And if you have a repertoire of answers that you can kind of fall back on, if you have this tool belt of different ideas that you can kind of pick and choose from as you're talking to manufacturing experts, you'll have a far better result. You'll look better in their eyes. They're more likely to take your project seriously and are more likely to give you a good quote because they then want to work with you because they know you've thought about all the potential issues, problems, and kind of hang-ups that are going to affect your project, just not only during manufacturing, but once it actually ships, how are customers going to receive it? How are they actually going to have an unboxing experience? How are they going to tell their friends if they even want to tell their friends about it? Maybe it's a product that sells itself, but you still need people to tell each other about it because it's the only way your product is going to get sold is through word of mouth. So just talking to people about your product is the best advice I can give. And it's funny because counterintuitively, a lot of people think, I'm not going to tell anybody about it. I'm instead going to keep it to myself, and then I'm going to have a big reveal at the end where everyone will see how smart I am because I have this brilliant project. But the problem is, in a silo, no one is all that smart. You need everyone else's critique and feedback and ideas you haven't even thought you needed to hear in order to make the best project possible. Apart from that, the only other advice I can have, and this does not apply to everybody, is to bootstrap if you can. Obviously, some ideas are perfect for venture capital. So if you have an idea that is maybe a land grab, or it has some components that are very expensive, maybe you're making new types of energy and you're doing fusion research, which I've met a number of people who do this, there are certainly avenues for venture capital that will push your companies to success. There are many reasons not to accept venture capital at the early stages. Once you have a product and it has growth and it shows traction, then talking about funding is an appropriate thing to do. But early on, you should be bootstrapping. You should be building as much of it as you can in your garage, someone else's garage, a shared workspace, as much as it hurts. Physically hurts to use a shared workspace where you have to deal with nincompoops who don't even know how to use the equipment, and you have to reserve time in 4-hour increments when you need 6 at minimum. Even though you have to do all these painful things, they help build your character, they tell a better story in the end, but if you can bootstrap, you end up finding out that maybe some things you thought were easy to do were hard, maybe some things that are hard are a little easier to do. You find all the problems, you work through them, and then if you're bootstrapping, you can kind of, I don't know where I was going with that, but you should bootstrap.
Thank you.